An atom's formal charge is the electrical charge difference between the valence electrons in an isolated atom and the number of electrons assigned to that atom in a Lewis structure. We show the bonds as separate electrons. A double bond is a 4-electron bond. Let's start with the uppermost oxygen atom. The total number of valence electrons assigned to this oxygen atom is 6, 4 non-bonding and 2 bonding electrons. Now, compare this number of electrons to the number of valence electrons in an isolated oxygen atom. Looking at the electron configuration of oxygen, we see that an oxygen atom has 6 valence electrons. Since the number of valence electrons is equal to the electrons assigned to the oxygen atom in the Lewis structure, the formal charge is 0. Next, let's look at the other 2 oxygen atoms. The total number of valence electrons assigned to these oxygen atoms is 7, 6 non-bonding and 1 bonding electron. Since the number of valence electrons in an oxygen atom is 6, and the electrons assigned to these oxygen atoms in the structure are 7, the formal charge is -1. A formal charge of -1 indicates that there is 1 more valence electron on an atom in the Lewis structure compared to an isolated atom. Finally, let's determine the formal charge on the nitrogen atom. Assigning half of the bonding electrons to nitrogen, we find that there are 4 valence electrons assigned to the nitrogen atom in the Lewis structure. Looking at the electron configuration of nitrogen, a nitrogen atom has 5 valence electrons. Since the number of valence electrons in a nitrogen atom is 5, and the electrons assigned to the nitrogen atom in the Lewis structure are 4, the formal charge is +1. A formal charge of +1 indicates that there is 1 fewer valence electron on an atom in the Lewis structure compared to an isolated atom. The sum of the formal charges must add up to the charge on the molecule or ion. Nitrate has a -1 charge, so the formal charges must add up to -1, which they do.